Let's now see the sequence of events that occurs around photosystem 1 and see how that relates to the Z-scheme. In our last lesson, we followed electron flow from photosystem 2 to pheophyton and then to the membrane-soluble component plastoquinone. From there, electrons are transferred to a multi-subunit complex of plant cytochromes known as the B6F complex. As you look at the schematic diagram on the right, perhaps you can see a resemblance to the mitochondrial electron transport chain. The B6F complex performs a function similar to that of complex 3 of the mitochondrial electron transport chain. As electrons move through the B6F complex, they are passed to a soluble component in the lumen, a copper-containing protein called plastocyanin. This functions very much like cytochrome C in mitochondria. Similar to PS2, the absorption of light by the P700 chlorophyll of PS1 is the primary event at this photosystem. This promotes an electron to a higher energy state with a low reduction potential, which is given to a molecule of chlorophyll A. The electron is then passed to a bound molecule of ferredoxin, which in turn passes it to a soluble form of ferredoxin. The soluble enzyme ferredoxin NADP plus reductase carries an FAD cofactor. Soluble ferredoxin passes the electrons to FAD to reduce it to FADH2. The reductase enzyme then passes the electrons to NADP plus to form NADPH. Recall that the electrons passed to NADP plus originated with the P700 chlorophyll, which was oxidized in the process. P700 must therefore accept an electron in order to return to its ground state energy and neutral form. This electron is donated by plastocyanin. By examining the net equation for electron transfer from PS2 to PS1, we can see that it involves the movement of electrons from water to NADP+. This is referred to as noncyclic electron flow since there is a terminal electron acceptor.